Okay, so this is going over the FIP quiz on 11, 19, 14. And number 1, ionization energy generally increases both up a group and across a period. Those are the two directions in which ionization energy increases. Which of the following atoms could you predict to have a smaller radius than bromine? These questions are tough. It was really easy yesterday when I handed you 5 elements and you can put them in order. You can do it like that because but there we're saying, okay, it does this down a group, I hand them to you, you put them in order. Okay, it does this across a period. Now I'm giving you 2, and in all these cases I tried to give you things that were both in the same group and the same period because I'm mean. So we have bromine that we're comparing, and we are comparing bromine to chlorine, potassium, iodine, and arsenic. Okay, we want to know which one's going to have a smaller radius. Well, we know that radii increase as we go this direction. So those two are both out. And I literally went through mentally kind of each of those and went, well, would that be bigger or smaller? Okay. We know that radius tends to increase as we go down a period. So iodine's out. Bromine would have a larger radius than chlorine. Chlorine would be smaller than bromine. So that's what you got to do. Okay, that was number 3, wasn't it? I completely screwed up that question, didn't I? Yes, I did. No, I didn't. I've only had 1 cup of coffee. I apologize. Okay, now we're talking about potassium. So potassium is what we're starting off with, and we want to know which atom we would predict to have a larger radius than potassium. And the things we're comparing to it are cesium, lithium, so 2 in the same group, zinc, and krypton, 2 in the same period. So here we're looking at radius. Well, again, radius goes up as you go down a group, and radius goes down as you go across a period. So these would both be smaller than potassium. This would be smaller than potassium, so it's going to be cesium. Okay, and in which of the following pairs do we list the atom with the larger atomic radius first? So the first 2 we're comparing are neon and carbon. They're in the same period. We know that radius goes down as you go this way. So radius, down as you go across, which means this is going to be smaller, so nope, not those. The next 2 are calcium and potassium. Again, calcium will be smaller than potassium, so that's not it. The next 2 that we list that we're comparing are bromine and fluorine. Well, we know that as we go down a group, radius increases, so bromine is going to be bigger than fluorine. That's our winner. Letter C. Number 6, again, pardon? I'm so sorry. Yeah, but I skipped explicitly answering it. You're right. So number 4, as you go from group 1 to group 18, atomic radii tends to decrease. Right there is your answer for number 4. The measured distance. Oh, yes. The measured distance between the nuclei of 2 identical bonded atoms. Well, once again, yeah, what I intended to write there is not what I wrote there. So half of the distance is the radius. The entire distance is the bond length, but we haven't talked about that, and we won't talk about it until the next chapter. So, whoops. Anyway, yeah, half the measured distance between the nucleus of two identical bonded atoms is the atomic radius. Okay, numbers 7 and 8. These were your little essays. Describe the relationship between atomic radius and ionization energy. This is short answer, and you could make it as simple as saying it's an inverse relationship. As one increases, the other decreases. You know, it's an inverse relationship. As atomic radius increases, ionization energy decreases. I didn't ask you to explain why on that. I won't rule out asking you to explain why at some point, and we'll probably practice that on the next FIP if I go for that. But you know, I would be pretty ticked at you if you attempted to get away with that as an answer, but it's true. As one increases, the other decreases. For number 8, I decided, 7 and 8 were each worth 2 points. So if you got a -1, I figure you missed about half of it. I decided that you couldn't get all the points for number 8 unless there was some reference or description of electron shielding, if you remember that from yesterday. So, some people said, like, well, you get more electrons. So? So what? What does that mean? If you add more energy levels, that's getting better. You add more energy levels, you have a larger radius. If you say something like, you add more energy levels, which increases the radius, plus, as you have more energy levels between those valence electrons and the nucleus can't exert as strong a pull on them. So the whole atom tends to get fluffier. A few people said the electrons got fluffier. Nope. The atom does, though. So, to get all the points for this, you had to, number 1, say that you add more energy levels. So basically you're adding additional electron cloud, making it bigger. But 2, there's some form of electron shielding that nucleus can't pull in valence E as tightly. Okay? The nucleus cannot pull in the valence electrons as tightly, so the whole atom tends to get a little fluffier. Okay? Overall, pretty good. And this FIP was certainly rougher than the last one. On the last one, I think I had 3 perfects, 9 out of 10s. Like, you guys rocked that one. That's okay, because what we did on the first FIP was really foundational. Like, you have to get that. Here, you still have to get it, but you're still processing the stuff you got before. So it's okay if you were a little bit shakier on this. You're going to get this also, because you'll be able to predict this in terms of reactivities. So, all right, we'll stop this video here, and we'll go on to some quick notes.